All right, so we're given this parallelogram and we're told that measure of leg or measure of diagonal JL is 28. That's over here. I'm going to draw a blue line over it. This is 28. So if you remember okay, you probably don't remember them right now, but I'll tell you to remember that your diagonals bisect each other. That means they cut each other in half. So this other diagonal that I'll draw in red, this one cuts the blue line in half. So we were told that JL, the long blue line, is in total 28. But we're also told that the red line cuts it in half. So JN, which is what we're being asked for, should be half of 28. So you guys can unmute yourself. What is half of 28? 28 divided by 2. What's half of that?
14.
Great, 14. So our answer is 14. But you guys probably are noticing that my problem is different than your problem, huh? So whatever yours is asking for, you have to adapt to it. So you can just use this as an example. I'm recording it. I'll put it on the website so you guys can see. So in my example, I now know that my answer is 14. I'll type it over here, 14. Submit answer. It says, are you sure? I say yes. And that's good. Okay. And then it also gives you an explanation, just in case you were like a lucky guesser. It gives you an explanation to make sure you truly understand. Now, if that wasn't enough, you can also click this watch help video, which is, here, let me scroll. At the very top right, you see where it says watch help video? I can't point because you can't see my finger, but on the very top, sorry, top left, it says watch help video. Let's do another problem together. I'm going to screenshot this so that I can draw on it. In parallelogram RSTU, if RV is 13, so that's this line. If that's 13, they want us to find VT. So remember, if RV is 1/2 of the bisect, that means RT has to be double that. So you can do 13 multiplied by 2, which is, just shout it out.
Five, 5.5.
Not divided by, multiplied by. Because look, or VT, sorry. I'm looking at the wrong thing too. My bad. Let me do that again. VT is, I gotta be more careful. Oops.
13.
Yeah, VT is 13 because VT is this line. So if I ever make a mistake again, you should catch me. If you do, that's great. Yeah, I'm a little bit out of it today because my internet's been so bad. Everything's just all over the place. But if RV and BT are part of the same diagonal, that means they gotta be the same length. So I'm not sure who said it was 13, but you're right. Good job. And also, thanks for catching my mistake. So let's save that to photos and put 13 there. Okay. So that's for this first type of problem. I want to make sure there's enough time for us to go through all the types of problems. So let's go back. Let's do dynamic quadrilateral properties. That's the second section. Dynamic quadrilateral properties. So here, we can drag around all 4 vertices of the following quadrilateral a significant amount until the vertex turns dark. Afterwards, drag and drop the properties of the quadrilateral that remain true no matter what as you drag the quadrilateral around. Can I zoom out? Not really. Okay, that's fine. So we're just going to drag this a bunch until the vertex turns dark. You can rotate it however you like, Just try to see if you can notice things. And then, okay, it looks like I dragged that one around a bunch. Okay. So now I'm done dragging them around a ton so that all my vertices have turned dark. And that's just so that they check to see, Deltamath is checking to see if you explored it. If you just dragged it a bunch, then that means you're exploring it, right? So after exploring for a while, determine which of the following properties are always true by dragging them to the right. So take a look at that first one. All four sides are congruent. Is that always true? All four sides, are they always the same? Like right now, are all four sides the same length?
No.
No, they're not, right? One of them is 3.56, another one's 5.5. They're different lengths. So it's not always true. I'm going to leave it on that side, okay? What about opposite sides are congruent? Are opposite sides always congruent? Are the top and bottom congruent?
Yes.
Yes. Are the left and right congruent?
Yeah.
Yes. Yeah. Good. So opposite sides, they're congruent. So I'm going to take this little bit and I'll just drag it over to the always true portion. Okay. So we're going to do that again for opposite sides are parallel. Remember, parallel is like they're never going to touch each other. So let's see. The top and bottom, are they parallel? Even if I drag it a bunch?
Yeah.
Yep, top and bottom are parallel. What about left and right? Are they parallel?
Yes.
Yes. Then I'm going to take that bit and drag it over here. All four angles are congruent is the next one that we're looking at. Are they all the same size? These angles? Even if I drag it longer, shorter?
No.
No.
I know it's hard to see, right? Here, let me. Well, this is, what kind of shape am I pulling around here? Is this a square?
Rectangle?
It's a rectangle. In a rectangle, are your four angles congruent? You can look at the notes paper. You can like switch screen for a second. Maybe it's hard to switch screens, huh? In a rectangle, all four angles are always congruent. Ah, why is it doing that? So I dragged it over to the right side. Okay. Opposite angles are congruent. So if all the angles are congruent, then the opposite angles are also congruent, okay? This, come on. Okay, there we go. It's a little bit hard to drag them on here, I guess. My bad. Okay, diagonals are congruent. Let's take a look. Those two dotted lines that make a cross in the middle, those are our diagonals. Do they look like they're the same length? In a rectangle, your diagonals are always going to be congruent. I'm going to drag that over. And the diagonals bisect each other. So now that we know it's a rectangle, if you look at your note sheet, you can also look down the list and you'll see that the diagonals do bisect each other. So I'm going to drag that over. And then take a look at the diagonals again. Do they intersect at a right angle? Do those dotted lines cross over in a right angle? Always? Look at the dot that says E. Does it look like those are right angles where E is?
No.
No, right? One of them's like a really, really skinny, narrow angle. One of them's a really, really wide open angle. So I'm going to leave that in the not always true section. Diagonals bisect interior angles. Okay, I want you to, let's see, can I zoom in? I can. Okay, look at where those diagonal lines touch the D and C angles. Does the dotted line cut angle D in half? Or does it give just a very small slice and a very big slice? Does the dotted line cut the angle D in half? No, it doesn't. Okay. So then we're going to leave it at the not always true column. And finally, the sum of all angles equals 360 degrees. That is true for every single quadrilateral. So you're going to drag it to the always true side. And then we're going to submit answer. And it gives us a check mark. Now, if it doesn't give us a check mark, that means something is wrong, and it probably gives you a clue. So you got to figure that out, okay? Let's go back. So we did those first two sections. Now we can do the last two, and then I'll give you guys time to work on it in class. So that way you guys can get started, and hopefully you have less homework. 3-step linear equations. So this is just a general review, and I want you guys to remember how to do this. We learned it early on in Math 1, but you know, it's been a while. So I screenshotted this so that we can write on it more. Oops, I meant to zoom in. There we go. Here's our equation, and we're going to solve for x. I'm going to rewrite our equation actually so that I have more room. 4x plus 1 equals negative 9x plus 16. So what you want to do here is bring your x values to one side and bring the numbers to the other side. So, for example, you can bring the 4x to the right, or you can bring the 9x to the left. It doesn't matter, both will give you the correct answer. But let's, in this example, I'm just going to bring the 9x to the left. Right now it is a negative 9x. So the opposite of the negative 9x is to add 9x. So I'm going to do that on both sides of your equal sign. So I added 9x to both sides. 9x plus 4x, that's going to be 13x, because 9 plus 4 is 13, and then the x just stays. The 1, you carry it down. The equal sign, you carry it down. Negative 9x plus 9x, they cancel out. They make a 0. And then you bring down your 16. So we have 13x plus 1 equals 16. And I'll pause here. Do you guys have any questions? Okay, so if you do have questions, feel free to interrupt me, type it in the chat. I will see it eventually. Or if you say something out loud, I will definitely hear you. But if you say something out loud, you have to unmute yourself first. Okay, so we're trying to get x by itself. So we need to move that 1. That 1 is so annoying, it's in our way. It's being added there, so we do the opposite. We subtract. On both sides, of course, because we need to, whatever we do on the left side of the equal sign, you have to do on the right side of the equation. Okay. Okay, so little side note, I'm going to pause right here. Okay, so let's continue. We bring down the 13x. The plus 1 minus 1, they cancel out. They make a 0. Bring down your equal sign. And 16 minus 1 is 15. You know what I just realized? I copied the problem wrong. There's a minus sign. Oh, okay. Let's put that negative symbol there. Okay, I mean, I know the answer to this bit, but you guys can help me out then. We just have to change this. What is 9x minus 4x when we combine it now? How do we fix this? What is 9x and negative 4x added together?
5.
Good, 5x, thank you. So we were bringing down a 5x over here. That's good. Okay. So then, how do we get rid of that 5 that's being multiplied to the x? What's the opposite of multiplying?
Divide.
Good, divide. So we're going to divide left side and right side by 5. So divide by 5. Then the multiply by 5 and divide by 5, they cancel out. They make a 1. So you get 1x is equal to 15 divided by 5. That gives us a 3. So we were able to solve for x. X is 3. And I think according to Deltamath, they don't want you to type x equals 3. They just want you to type 3. Okay, so we're going to just submit the number 3. 3. Submit. Yes. Okay, and then they also give you a little explanation here. So they pretty much did the same steps. And I forgot to ask, does anybody have a question on this one? Okay, feel free to interrupt me if you do, but I'm going to go to the last section. The last section is angle terminology with equations. Okay, so this one says measure of angle A and measure of angle B are vertical angles. If measure of angle A is equal to 3x plus 13 degrees and measure of angle B is equal to 5x plus 9 degrees, then we have to find the measure of angle A. So I'm going to reach out that. Maybe this looks familiar to you because this topic was actually given to you in the last homework also. But we're still going to go over it a little bit. So for vertical angles, according to our note sheet, vertical angles are equal. So what we're going to do with the measure of angle A is set it equal to the measure of angle B. Because vertical angles are equal, so measure of angle A is equal to the measure of angle B. So they're equal, so then we can put their equations as equal. Questions up till here? Okay. So remember, if you do have a question, you should tell me, otherwise I won't know. So from here, we can solve for x. So we want to solve for x first. So in order to do that, let's bring all of the x pieces to one side. So I'm going to choose to bring a 3x to the right. And I do that by subtracting 3x on both sides, because that's a positive 3x. So you want to minus 3x on both sides so you can get rid of it. Those will cancel out. Bring down your 13. Bring down your equal sign. This gives us 2x plus 9. All right, you guys can help me out. What's my next step? How do I get rid of the 9?
Cut both sides by 9.
I couldn't hear what you said. Sorry.
Subtract both sides by
Okay.
9.
Yes. Subtract both sides by 9. So right now it's a plus 9. So to do the to get rid of it, you do the opposite. You minus 9. Subtract 9 from both sides. And then you get 13 minus 9, which is 4, is equal to, bring down your 2x, and then those cancel out. Let me rewrite 4 is equal to 2x over here, just because I have space here. So there we go. 4 is equal to 2x. Any questions up till here? Okay. So this x is being multiplied by 2. So what should we do to get rid of that? What's the opposite of multiplying?
Dividing.
Dividing. Good. So we divide by 2. because this is being 2 times x, 2 multiplied by x, to get rid of it, you divide by 2. So they cancel out. So 4 divided by 2 gives us 2 equals x. However, that's not our answer yet. It says find the measure of angle A. So you have to plug in this x into our A equation, which is here. Measure of angle A is equal to 3x plus 13 degrees. So that's what we're plugging it into. Measure of angle A is equal to 3x, our x was 2, plus 13. I'm running out of space, so let me zoom in. So the measure of angle A is equal to 3x plus 13. So we just plug in the x value over here. So 3 times 2 plus 13. So that will give us 3 times 2 is 6 plus 13, which will give us 19. So now we have our final answer. Measure of angle A is equal to 19. So what questions do people have? Okay, so I'm going to enter this into, Deltamath. 19, submit answer. Are you sure? Yes. And then there we go. So vertical angles are equal measure. They can also give you a supplementary or they can give you a complementary. Let's see if they can give us one of those for another example. Vertical angles.
I have a question.
Yes, question.
What do vertical angles equal up to again?
They equal each other. So, like, let me go back to my photos. Ooh, there's a lot of photos. Oh, what? Is that what it saves as? Just because I zoomed in like that? Can I undo it?
You
Revert.
put the two equations to like equal each other instead of equaling.
Yeah.
One. Oh, okay.
Like, I can like point. Over here, we just put those two angles to equal each other for vertical.
Oh, okay. Thank you.
Yes, you're welcome. Okay, so then for here, I just clicked example because they gave me another vertical and I wanted to see if they could give us a supplementary or a complementary. So remember that supplementary angles are the ones that add up to 180 degrees. So you can see that in the explanation of this example here. Let me point. See right here, it says supplementary angles add up to 180. So this time, because they asked for supplementary, we're not setting them equal to each other. You say A plus B equals 180. Okay, so it varies depending on what they ask of you. Any questions on that part? Feel free to interrupt me if you do, okay? So in this case, they combine the two angles. So they just took away the parentheses first, and then they took the 2x and the 2x and they turned that into a 4x because 2x plus 2x is 4x. They also combine the -6 and the +10 to give you +4. And then from there, they wanted to get rid of that +4 by subtracting 4 on both sides. That's what's going on here. Subtracting 4 on both sides to get rid of it. Then you just get 4x is equal to 176. Then because 4 is being multiplied to x, they divided by 4 on both sides. Okay, so you guys have access to the example problem as well. And yeah. So just remember, supplementary angles add up to 180. Vertical angles are equal. And there's a very similar method for complementary angles. Complementary angles add up to 90, but it's the same process that is shown here. Do you guys have any questions? No? Okay. Then let's go back. And that was the 4 categories. So for the rest of class, I'm going to put you guys into breakout rooms, and I want you to just work on assignment number 9, and then I'll be jumping through the breakout rooms to see if you guys have any questions. And hopefully, if you were too shy right now,